Hi everyone, I'm Omar. I'm originally from Peru, although I grew up in Mexico at least for high school and college. I've been working first as a software engineer in Google Assistant. Then I joined Hugging Face at a very early stage, working in the open models ecosystem, building integrations with different open source tools, really making sure that the open models are as accessible as possible to the developer ecosystem. And since 7 months ago or so, I joined DeepMind to work in Gemma. If you don't know Gemma, it's the family of open models from Google. I'll talk a bit more about that. And today's talk will be about open models. I'll talk very briefly about use cases, fine-tuning, and the tooling and the ecosystem as a whole. It's a very complex topic with many different moving parts, so consider this as a high-level view of the state of the world right now. Let's get started. So as I was saying, Gemma is, so there are many hundreds of, even thousands of official open models by different companies, research labs, institutions. From DeepMind, we have released Gemma. Gemma is a family of open models based on the same research as Gemini. And open models means that these are model weights that you can download. You can run this in your computer, maybe, it depends on the model size, but you may be able to run these models in your computer, in your phones, in your own servers. So you have actual control and ownership of the weights in some way. It's a way to really make machine learning more accessible, right? So, for example, you can run some of these Gemma models in an iPhone or in an Android phone rather than having to call a server. You can do things called you can modify the model for your own use cases, and I will talk a bit more about that. What is quite exciting is to see the growth of the developer ecosystem. So we released the first Gemma model about a year ago, in March of last year. At the beginning of this year, so just 6 months ago, we had 100 million downloads, and we saw a 50% growth just in 5 months. This number is a bit outdated, so I computed some numbers earlier today. Today we have 170 million downloads, so it's very exciting to see what the community is building with Gemma. And again, this is just for the Gemma models that we have released. There's a whole ecosystem of open models that you can use. And within DeepMind, we have released a couple of different things. So we have what we call the core Gemma model. So this is similar to Gemini or to ChatGPT. These are models that will generate text based on an input. These are generalist models, so models that you can chat or models that you can fine tune or modify for your own use cases. So we released Gemma 2 last year, Gemma 3 just a couple of months ago. And then we released Gemma 3N just 3 weeks ago, which is a model specifically for on-device, so for running the models in a phone. Apart from what we call the core Gemma models, we have also done what we call variants. So for example, we released just a few weeks ago MedGemma at the bottom, which is a Gemma model for medical use cases. In the context of open models, the medical domains are quite interesting because there are many privacy concerns that many people, many health-related institutions want to keep the data local. They don't want to send data to any servers. So it's quite interesting to see the adoption that MedGemma has been having in just 3 weeks it's been out. And similarly, there are other projects such as CodeGemma for code-related generation, ShieldGemma, which is more for safety applications, or SignGemma, which is to do sign language back to English. That's for the American Sign Language, and there's ongoing work with different institutions to do a SignGemma version for Indian Sign Language, for example. There are a bunch of different sign languages. And as I was saying just a few months ago, we released Gemma 3. It comes in different model sizes from 1 billion parameters all the way to 27 billion parameters. And the goal is to share some of the best open models that can run in consumer GPUs. That means that these are models that you can most likely run in your own computers at home without having to buy extremely expensive GPUs for computers. These are multimodal models. That means that you can pass text, images, short videos, and for some of the models, even audio as input. We have done lots of work in multilinguality because at the end of the day, the goal is not just to share models that work for English, but rather models that work across a large number of languages. So we have worked to make sure that Gemma works well for 140 languages, and also that it has a large context. So if you're not familiar with context, the idea is that when you pass text to a model, there is a limit of how many words or how many tokens you can pass to the model. Gemma originally had a very short context, so just 8K tokens or parts of a word. And with Gemma 3, we released a much longer context model. So you can share up to 128K tokens, which is equivalent to 400 pages of text or 500 images. So it's not huge, but for the local inference, it can be quite exciting to see what the community is building with this. And then you can kind of mix multimodality with multilinguality. So for example, here, what you can see is that you have an image that has text in different languages, and the model can have a good understanding of multilingual, multimodal situations. So in this case, an image with text in different languages. And what is very important in the open source ecosystem is really to focus on the community. So talk with the developers, understand what researchers are doing, how people are deploying these models, and really add new features. So for example, the long context was one of the main feedbacks we had for the Gemma 2 and previous models. So try to iterate quickly based on the community feedback. There's something called LMCs or LM Arena or the chat leaderboard. It's all the same. It's a leaderboard in which users, anyone, so you can go to this leaderboard yourself. You can chat, so you can type something, and you will get 2 responses of 2 different models. And these responses are anonymous, so you don't know which model generated which response. So what you can do then is pick which is the generation that you like the most. And after thousands of chats and submissions from different people, you can build some leaderboards, some ELO scores, so similar to chess, in which you can see which models are more preferred by the community. It's not a perfect leaderboard, as all of the benchmarks and evaluations in the machine learning ecosystem, all of them have some issues, but it's a very good proxy to understand what people like the most. So you can see here in blue the Gemma models. All of these are just open models, so models that have open weights. And then the dots at the bottom is the number of H100s, which is a type of GPU. You can replace this with a A100. It's the number of GPUs that you would need to just load the model. So you can see that there are some models that are better than Gemma, but again, our goal with Gemma is not to make the best models, but to make the best models that users can actually run for their own use cases. So we are quite excited about the results that we have been able to get. And as I was sharing, our goal is to make it strongly multilingual. So it's kind of, I don't know if you can see it, it's here almost at the bottom after the half. After the middle, you can see Gemma 3, the 27 billion parameter model, does kind of well for English compared to other models that are proprietary, but it has very good performance actually for French, Spanish, Japanese, and Korean. And what is even more exciting is the part of fine tuning. And now I'll switch from talking to Gemma to talk a bit more broadly about the whole open source ecosystem. So there, we have been working very closely with this developers, so people that are developing tools for developers, to make sure that when we release Gemma or other models, people can use the models very easily. So, for example, Google, of course, has its own library. So it has Keras, it has JAX, but the reality is that many people are using PyTorch, are using Hugging Face transformers, are using Olama to run the models locally. They are using BLLM to deploy the models in a server. So we're working very closely with all of these tool developers to make sure that they can use, that their respective communities can use the models easily. So for example, if the simplest way to try out Gemma without having to install anything is just to go to AJ Studio, and it's a free interface where you can play out with Gemma. But of course, the cool thing with open models is that you can run the models in your computer. And here's a very minimal code snippet for Hugging Face transformers, where you can create a pipeline, and in a pipeline you specify which is the task. In this case, generating text. You then specify the model, so Google, the Gemma 3, 12 billion parameter, and then you can pass the text, the prompt, who are you answering pirate speak, and that's pretty much it. And again, it's the highest level abstraction of the library, but there are many other interesting things that you can do with this. So far, I've been talking only about doing inference or running the model, but where things become interesting is in actual doing training. So in the world of LLMs, you have two stages. You have pre-training. So in pre-training, you train a model with massive amounts of data. It's very expensive usually, computationally speaking. So you need lots of data, lots of money in compute, and you need expertise in the team to be able to do these models. The outcome of this stage is a next token predictor. So it's a model that has some kind of statistical understanding of the training data of the text, and it will generate the next token. But when you interact with ChatGPT or with Gemini, you are not expecting the model to predict the next token. You are having conversations, you are having a chat. And this is something that the pre-trained model doesn't do out of the box. You'll do something called post-training. So if you have heard about fine-tuning, RLHF, post-training, all of these fall like in this bucket. And here you are shaping the behavior or the personality of the model. So if you want the model to be a chat or a conversational model, this is where you do it. And here you require much less data. You can train the model on a targeted data set. And this is what really turns a next token predictor into a product. So just to go a bit deeper, why to fine tune? So the first of all is if you want to add new capabilities to the model, right? So let's say that you have a model that kind of works well in Spanish, but it's not great. So maybe you have your own data set of text in Spanish for certain dialect or certain version or certain region. You can improve the capabilities of the model for that language. Or if you want the model to be able to do object detection for image inputs, you can have your own data set with just a few hundred images with the object detection labels and use this data set that you have to improve the capabilities of the model for your own use case. The second part is, well, the first two points are a bit connected, but also like changing the style, right? If you want the model to be very conversational, or if you want the model to be very concrete in the responses, this is where you do it. And then what is very common in the industry, you may have your own use case or domain. So you may be working in finance, or you may have your data set of internal use cases. So this is data that you cannot just share externally, or you may not even be able to train a model in another cloud or in another place that you don't control. And this is where open models fit very well, because you can customize the models without that much data for your own use case. And there are a couple of different ways to do post-training. I will not dive too much into this because it's for a longer talk, but the most standard way is to do something called supervised fine-tuning. And here you pretty much have a data set of prompt response, let's say. And the idea is that the model should be able to predict the response based on the prompt. And standard fine-tuning should be done if any existing instruction model, so any chat model or any model that does instructions, does not work out of the box for you. And if you need to keep pushing the performance, but before just doing fine tuning, you should just try prompting the model and see if it works out of the box. Sometimes fine tuning a model is not that cheap because you need to iterate a bit, you need to compute. So you may also want to at least check if a larger general model will work better than a super small specific model for your own use case. And as I was saying before, if you require specific formatting, so certain chat structure, if you need the model to output code in certain format or some style decisions, that's what SFT is for. There's also something called RLHF, or reinforcement learning from human feedback. And it's not one or the other. Usually this work has different stages in a longer pipeline of post-training. RLHF, the idea is that you can define some reward signals that predict which is the response that humans prefer. So for example, maybe it's knowledge related, as in the example here, but maybe it's more like based on the style. As I was saying before, if you want the model to be very quick on the answers, or if you want the model to be very chatty, those are things that are incorporated in this reward signal. So maybe you don't want the model to add emojis in the responses. So if the model has some emoji in the response, you may want to have a negative signal here. But there are much more complex reward signals related to code, for example. So you may want the model to generate code, and you may want to execute the code. And if the model is the code that was generated by the model is not executable, you may want to have a negative reward signal to avoid the model generating invalid code in the future. And again, there are many different tools for doing fine-tuning. One of them is called TRL, which is a wrapper around the transformers library. And they have out of the box nice recipes for RLHF, SFT. For RLHF, they have different optimization techniques with different recipes. So there are lots of resources around this. It's very experimental, empirical. There's good research behind this, but at the same time, lots of this kind of iteration work is really iterating. Many times it's just improving the data, and actually, most of the work I would say is on the data. But there's some very interesting work in post-training techniques. And what you see here in the leaderboard, this is the same one as before, what you see here in the leaderboard are the results of the post-trained model. It's not the pre-trained model benchmarks. For those, you usually have other kinds of benchmarks. Something that you may be wondering is, can you run these models? And you can do some rough napkin math, and pretty much just to load the model, you can say, okay, I multiply by 2, and that's the number of gigabytes that I would require just to load the model. So for example, for a 27 billion model, you may require 55 gigabytes, a GPU with 55 gigabytes, which you probably do not have. And here I'm putting bfloat 16, which is the precision. So if you understand like models, 27 billion means that you have 27 billion parameters or numbers. Each of those numbers have some precision. That means how many bits you're using for every single of those 27 billion parameters. So bfloat 16 means 16 bits, but you can use fewer bits to load the model. And of course, the quality degrades because you're kind of truncating or cutting some of the bits. But this allows you to run, for example, a 27 billion parameter model in 14 gigabytes rather than 54. So this makes the models much more accessible, but you have a quality loss. So there is something called quantization-aware training. Quantization-aware training is a technique that makes the model more robust to quantization. So pretty much it is an additional post-training stage with very few samples, maybe 5,000 samples. And after that stage, you can quantize the model for a specific format while preserving the same quality as the original model. So for example, rather than require 2 gigabytes to load the 1B model, you just need 0.5. So this is the same as the previous table, but it's a bit nicer. And just to wrap up, I want to share some interesting case studies that we have seen by different institutions. So AI Singapore, they did something called Sea Lion. It's a model trained for 14 Southeast Asian languages based on Gemma 2. So they picked Gemma 2, they had their own data sets, and then they push further the capabilities of Gemma 2 for those 14 languages. And this is an open model now that anyone can go and benefit from. Here it's the same model. Here you can see at the top right, this is the Sea Lion model based on Gemma 2. And you can see that it's doing very well, both for English, but also for the C, so for these 14 Southeast Asian languages that they were targeting for, compared to maybe the raw model that was here. And this is just one example. There are over 70,000 models, open models in the open source ecosystem based on Gemma. And again, my goal here is not just to share about Gemma, it's more to talk about the power of making things open, making things community driven, and sharing with the ecosystem. So we have seen CodeGemma, which is for Korean conversations, to Gemmax for translation, to applications for retrieval augmented generation in Arabic and English, to generating images, to having audio as input, to even doing new research such as new preference algorithms. So it's quite exciting to see all of this huge ecosystem growing around Gemma. And we have done things such as a Kaggle competition a few months ago, in which we were collaborating with the community for them to train Gemma models for their own languages. We saw over 7,000 entries. Out of this, there were some very exciting projects, even like ancient English, for example, to very specific low resource languages. And just a few weeks ago, again, this was on the 22nd of May, we released Gemma 3N, which is a model optimized for on-device. And for on-device, I mean running in a phone or IoT or in your browser. With expanded multimodal, so it has audio input, and it has a new architecture called Matformer, which allows you to extract submodels submodels down to one to 2B actually from the main model. Don't worry if you don't understand that part, but what is exciting is that you just need 2 to 3 gigabytes of GPU to actually run this model. So again, like this can lower the barrier of entry to experimenting with these models quite a bit. And it's a very nice model. It does a bit better than the previous Llama 3 4B model that we had. And it seems to be liked quite a bit by the community. So that was pretty much it from my side. I'm very excited to see what the community keeps building from our side. We plan to keep shipping models. And again, my goal of this talk is to share a bit which are the tools of the ecosystem and to share a bit this kind of collaborative mindset. I think the goal is not to have the whole pie, but really grow the pie. There's a huge model, like huge ecosystem of open models. Hugging Face has over 1.5 million models right now, open models right now. And I think all of us are pushing together the boundaries of open machine learning. So it's quite an exciting moment. Thanks.